So my name is Gabriele. So I done a lot of things in my career. If you just happen, it's very rare, but if you happen to have seen one of my talks previously, I'm usually about functional programming in Scala and a bunch of stuff, which is not what I'm going to talk about today. So it turns out that in the past, I would say 4 years, I've been mostly dealing with design systems, of course, a bunch of other things, but design system have been like one area of focus of mine. I didn't mention, I'm co-founder and CTO of Buildo, which is a software development company in Milan. And we do a lot of things. Among these things, we also worked on some big enterprises design systems. So like many developers working on these design systems, using these design systems. Same thing for like smaller companies. So we eventually decided that it was time for us to build our own design system that we use for our clients. And this is called Bento, which is not a sales pitch. So I'm not selling you on the product also because it's mostly free, but I want to use it as a case study today for something that I want to talk to you about. So Bento is a design system for the web. It has a development side, which is React and TypeScript, and it has design side, which is a Figma library plus a lot of documentation. And it's open source, has commercial support in case you're interested, in case just let me know. But again, this is not a sales pitch. You can find everything that I'm talking about on the website. You will also find links to the GitHub repositories, and we will actually look around some pull requests later in the talk. Maybe, and you will understand what I mean in a second. So before we move on to the technical part of the talk, I want to talk about design systems, because it was in the title, right? So you're in here, so I suppose you're kind of interested in that, or maybe the other room was too busy, I don't know. So raise your hand if you're familiar with the term design system. Not because it was in the talk title, okay. Just promise it was not the first time you're hearing about that. Okay, raise your hand if you could explain it to somebody. What is a design system? Okay, 1 hand, 2 hands, 3 hands, okay, way less, okay. Great, so I'm not gonna ask you. It's a safe space, so you're not going to be asked to interact if you don't want to. But let's go to a standard definition. I'm not going to read it to you because you can read, but essentially what we can summarize is that a design system is something that we use to achieve consistency. And consistency is something that it could be across the same product. So whenever you change page, you're not like, hey, this is a different button. Did I change website? So that happens. Or across many different products, or maybe the same product across different devices. So this is something that we want to do, and this, again, is a standard definition, but it's one of the many possible definitions. And today I would like to break down what a design system is so that we can have a shared vocabulary for what comes next, okay? So a design system should have, my personal opinion, I'm not the only one sharing this opinion, fortunately, a few things. And these things may be foundations, components, UX pattern, governance, and whatever you read on the slide. So foundations. Foundations are, well, the foundations of the design system, so the atoms, if you will, something that you cannot break further. So I'm not talking about atomic design, which was mentioned previously, but that it's a way of structuring things. Foundations, you can think of stuff like colors, spacing, rules around which kind of animation we're going to use in the design system. What is a typography? What does it mean? What is the meaning attached to the typography that we're using? Like we're using titles, but we're using titles for, I don't know, page, high-level content in the heading of the page. You can use these foundations to build components. And this, by the way, is what separates a design system from a component library, which is a subtle definition, but sometimes you think of design system like, hey, yes, this component library that I found on NPM. Components are usually built on foundations on design system and not necessarily, this is not necessarily true for component libraries. So some component libraries are just a collection of components that don't necessarily share a common foundation. So components built on foundations can be part of a design system. And this is very important because building a thing on the same foundation essentially allows you to keep it consistent amongst itself. So components are easy to talk about because they exist in React, but they also exist in Figma, for instance, if you're using Figma. Like a symbol in Figma is a component. It has a name, you can reuse it, you can configure it. So it fits the definition of a component. And that actually facilitates the dialogue between design and development because we're kind of talking about the same thing. And Then we move on to something slightly less obvious, which is UX patterns, for instance. So sometimes people think of a design system as something that you can take and use, right? So you can say, hey, this is a component, I'm using that button from that design system, right? But design systems are also, in my opinion, a very good a very good spot where to put a lot of shared information that you may have painfully reached an agreement to alongside the life cycle of a project, of a product. For instance, do we do validations in forms when we submit or when we move around the form and the user blurs on an input? I don't know. There's plenty of research. Go read it. But once you get to a decision, there are nuanced decisions based on the context, but write it somewhere. And I would argue that the design system documentation is a great spot where to write this thing and have it agreed on, and so that works the same across your products. So similar examples could be like navigations, or it could be how do we do handle navigation, or how we handle notifications to the user. So things that are not tangible in the sense that you can take and use them, but you can use the components to implement the pattern, but please document the pattern because that helps everyone involved. And finally, if you did all that, and then you stopped, and you don't have a way of moving forward and evolving this design system, congratulations, you just worked 6 months, a year to build tech debt. Because if you don't have a way forward, you don't have governance. By governance, I mean some kind of processes that help you incorporate feedback, change the design system, evolve it, improve it, add new components, deprecate older components. Please have something, even like 5 lines of markdown put in a README somewhere. Like, you need to have something, because otherwise what happens is that you get into a company and we have a design system, of course. How do I make a change? I don't know. If you need, send a pull request over there, talk to that designer, maybe someone will help you at some point. So that's not governance, that's like, I don't know, chaos. And that happens oftentimes because it was not thought about in advance. So please, if you build a design system, have some kind of governance. That's maybe the most important thing here. You can start wrong, but if you have a process to improve, you will get better. If you start perfect, by then you don't move, you just go rot. So then you can add whatever works for your context, by the way. So if you're if your company is very sensitive, for instance, about copywriting, you can have copywriting guidelines in the design system. That's a perfect spot. So whatever you can share, which is around consistency in the design and then the final implementation, please use the design system as a repository to host all this knowledge. But let's move to today's topic, which is more on the technical side of things. So I wanted to talk to you about a few topics. And these topics are about building a design system using React specifically, and TypeScript, as we will see. I have 4 topics for you today. So if we go over these 4 topics, it's gonna take roughly an hour and a half. So close the doors. No, I'm joking. So we have 4 topics. I don't have the time to go through all of them. So you decide. So I'm gonna pitch you all the topics. These are 4 topics, and you're gonna pick 2, okay? So this is the moment in the talk where you pay attention if you care. If you don't care, I don't know. So I'm gonna pitch you the topics. Topic number 1, Vanilla Extract, which is a CSS library which we use in Bento, and I wanna explicitly talk to you about why I think it's a good library in general, and why it's very suitable for building design systems. Not the library specifically, maybe, I will talk about the library, but even the library approach is useful, so it will guide you into choosing the kind of library that you might want to use for authoring styles in a design system. Topic number 2, everyone's favorite, testing. So how do we do testing in a design system environment? What does it mean? What is a unit test? What is an integration test in the context of a design system? How do we approach testing in a design system? Not trivial. Number 3, accessibility. So as we approach the 2025, people start to notice that accessibility is a thing, because in 2025, we have the European Accessibility Act coming into place. So normally, companies are panicking. So we're selling a lot of assessments, which is great for my business. It's not the most important part, but I want to talk to you about the role of a design system in terms of accessibility. How can a design system can help achieving accessible products? And concretely, what do we do in React? Finally, this is by far my favorite, and this is by far completely non-related to design systems. I mean, it's a trick that we use in our design system, but I desperately wanted to talk to people about this. It's a weird TypeScript trick that we use for creating an API for our design system that allows us to make localization of components a little bit more type safe. And again, this is absolutely not about design system. It's a library technique in TypeScript. If you absolutely hate complex TypeScript types and TypeScript techniques, absolutely don't vote this one. If you want to make me happy, vote this one because I like talking about this. So now you have a minute in which I'm going to get a sip of water. If you cannot vote in a minute, you lose your right to vote. Sorry, this is not democracy. It's a technocracy. And I'm going to carefully try to go here and see whether this works. Huh? Oh, yeah, sorry. There you go. All good? Everyone get it? Okay, let's find out. How do I do this? Oh, thank you. Okay, 82. Wow, you're a lot. No, but I need to go to my profile or something. Sorry, I'm not an expert on this topic. So, Jesus. How do we see the results? Maybe here. Do I just go on slido.com and then maybe log in? Sorry, I should have this prepared. I thought I had it. And I'm in fact logged in already. So let's see. Haha, okay, maybe I biased you a little bit too much on there. Okay. And testing is amazing. So this is not the first time that I do this talk. I never talked about testing, so great crowd. Okay, so I'm definitely not gonna start from the weird TypeScript technique that it wasn't gonna kill you all before the topic is over, the talk is over. So let's start from the testing side of things. All right, so I need to go back to the slides. Yeah, that worked, nice. Okay, so this is now what you're not gonna get. This is not what you're going to get, but you can see that I actually had this prepared. It's not a sleight of hand or of sort. By the way, I'll be here like till the end of the event. If you're curious about the other topics, we can have a chat. You will find me around. I'm the one with the pink hoodie. So testing, all right. So, okay, we're like writing a library, right? So we want to test stuff, right? So if you go about testing and you generally think about testing like in these terms, right? Roughly, if you've been through some kind of education or blog posts about testing, you typically end up in a testing pyramid. So you have unit tests at the bottom, you have a lot of them, they're really quick for iterations in local development, and then you have integration tests, a little bit less, but yeah, they integrate different things, they're maybe slower, but you have fewer of them. And then you have end-to-end tests like business flows and whatnot. Amazing, but what does it mean if you have a library of components? Like, what is an integration test? I don't have a database, right? If you read a blog post about unit tests, they're like, hey, suppose you have a calculator and you have a function that sums two numbers. And you're like, I don't have a calculator, I have a damn React component. What is an input? What is an output, right? So it's not immediately clear how to approach these, especially it's more front-end related stuff, but even especially component library things are not obvious to test, I would argue. So let's take a step back, right, and ask ourselves, why do we test things? Is that because we want to feel good about coverage information? Like, is that something that you do? Or sometimes I do. Or because you read it in a book, or because we want to check that the code works, right? That's a good answer. So I would argue that we write tests to prevent bugs from reaching users. So bugs that don't reach the users are okay. We can leave them there. Okay, if the bug is noticeable and it causes problems, then that's a business value that we want to manage. Okay, it could lower the value of the thing that you're producing. It's very abstract, but in terms of components, if you have like a tiny bit of the thing that nobody notices ever, I would argue that in terms of trade-offs, you can leave it there and focus on different things. So preventing bugs is different than testing the code. You need to focus on preventing bugs. And sometimes that doesn't involve testing the actual code. So let me explain. So we're writing a component library. Okay, assuming and that's like 500 slides that we skipped before about accessibility, assuming that the hard stuff you delegate to a library or something else that is tested, right? So in the accessibility part, I would have talked about how we use like React ARIA and okay, something like that. And assume that's tested. So unless you have a lot of complex logic, that's not your main concern. Your main concern is a bunch of CSS that needs to look good on the page, right? And the component needs to essentially do what you're supposed to do. When you click it, it opens the dropdown, it does what it needs to do, okay? So I would argue, and you can disagree with me, but I would argue that most bugs that you have in these kind of projects are visual bugs, or at least manifest as visual bugs. So even if you have an issue which is not necessarily a visual issue, the CSS is fine, but you have some mess with the JavaScript, it will look like shit, right? It will break something. Something will essentially not work correctly, and you will see it. So what do we do? Do we snapshot everything using VTest or snapshot testing or something like that? Dear God, no. I would argue that's most of the time useless, borderline dangerous. And I'm going to try to explain myself. Snapshot testing has its purposes, and it can definitely be very useful. But in my experience, not for like component, the code outputted by React components or components in general. So the main point is that code changes not necessarily affect the UI. And I will show you an example, but most of the times I'm working on Bento, for instance, anything I do, I do not want to affect the UI. So most of the times I'm fixing something, I'm refactoring something, and I just want to make sure the UI doesn't change. So in that case, if you snapshot in the code, you basically giving yourself not much to work with. It's essentially you constantly updating the snapshot because it changes all the time. And as a general rule of thumb for any kind of testing, if every time you touch the code, you need to also touch the tests, something's wrong with the tests, okay? So this is a kind of a general thing that I stand behind, because the testing should stay more stable than your code. Otherwise, I don't know what you're testing, because otherwise you're just writing the code twice, okay? Plus, snapshots may not catch what you're looking at. So maybe the snapshot of the code you're looking at doesn't change, but nevertheless, the change you reintroduced, changing something somewhere else. That's a little bit more subtle, but it can happen. So I would argue that we can do a lot better than that. And let me introduce you to the world of visual testing, which may seem like a joke at first, but if you consider that the fact that most regressions that you have in a design system component library are visual, having something like this can help you a lot. And it basically, even as I mentioned before, even if the bug is not directly visual, it will pop up in some visual way. Something will be off on the screen most of the times. Again, we're aiming for most of the time, and then you can add more tests to compensate for that, but we're like tackling the big things. So this is an example of an interface of a tool, which we'll talk about in a second, but we have, okay, this is the one-up view, so it will overlay the two things, and the green stuff is like there to make it obvious what's breaking. So here, in case it's not obvious, I introduce a change, and this is from 2 days ago, so fairly recent in my memory, and well, I messed up the layout of this field, right? So it will clearly show that this is going, is wrapping, it shouldn't wrap, and you can also have a two-up view where you compare them with each other. So it's very useful, it's very immediate, and this runs on a pull request. Okay, so you can think essentially of visual tests as the base of your pyramid, as much as unit tests are in a different environment, maybe a backend environment, because you want a lot of those, and you want them to be cheap to write and maintain. So I will introduce the tool that we use. It's not the only approach, but it's the most effective in terms of like development hours and cost that I've found so far. If you know of other approaches, please do come to me, because I regularly check whether this is still a good approach. We use Chromatic, which is, you may or may not know it, is the tool of the company behind Storybook. So if you show of hands, who knows about Storybook? Okay, the biggest part of the room. Okay, so Storybook is a tool for authoring stories, so you can render a component in a specific state. Okay, and for a component, you can write many different stories, and each story is like a permutation of the state. So you can have a storybook for a button, and the button will be like the story for the button in primary state and the normal one. Then the primary button in a disabled state, the secondary button in a primary state, and so on and so forth. So if you have that, you can just take it, give it to Chromatic as a tool, and say, go and do your thing. It will run all your stories in a real browser or multiple browsers if you tell it so, and it will take screenshots in real browsers of this thing, and it will compare it to the main branch. So on every pull request, you get these essentially for free, or for $149 a month. But yeah, it's not free, but again, I would argue that my work to come up with something like this is way more expensive. So, you know, I mentioned it's a compromise in terms of like what you're paying as for a software as a service, which I'm not getting any fees of, by the way. If anyone knows of a free alternative, please do come to me. And it basically built by the snapshot. So every snapshot it takes, it builds you like a fraction of a cent or something like that, and it will essentially accrue to these for the starter plan. I think we pay for a complex project like the step further, so like $200 or $300 a month, something like that. Very, very interesting. I will show you an example in a second. Why specifically Chromatic? Because it's the only one I found, first of all, that does this thing in this way. And also it's very nice because it has real browser snapshots. As I mentioned, if you care about browser compatibility, you want to test these things in a real browser. So it will test it in like Safari, and which is the new Internet Explorer in that sense, Edge, Chrome, or whatnot. Of course, you pay more if you test more browsers. So we do mostly Chrome and Safari. Has multiple viewport support, which is nice. So you can configure a storybook for a story to say, hey, please snapshot these in a desktop resolution and a mobile resolution. So we'll not use a mobile device, but we'll at least shrink the window. So if you have some responsive things going on, that will help you. It's integrated with GitHub pull requests, and it works well also for design review, which is something non-obvious. So it's not just for catching bugs, but as you are developing a new thing or a new change to one of your components, you can use the tool to dialogue with your designer because it has a full-on web interface where you can leave comments on the thing. So it's very useful as you're developing. And actually, I'm gonna jump into an example. I should have it already here somewhere. Okay, so I want to show you an example. So this is the Bento repository. It's open source, so you can actually go check it yourself if you want. If you look at the latest merge pull request, is this one. Okay, so a little bit of a backstory. So we have an input component. I don't have a screenshot, but it should be clear enough. An input component that has like two things, one on the left and one on the right, because inside the component, sometimes we want to show a little thing. So imagine a number field, and at the end of the number field, inside the number field, you want to show like the currency or something, or the unit or something like that. We call those like right accessories or left accessories. The naming comes from iOS for some reason. So many months ago, I was probably drunk and I decided to do this using absolute positioning, which is a horrible idea, especially because it means that we basically render the thing, and then client side, we measure the accessory, and then we shift everything to make it work with paddings and stuff. I don't know why I've done that. I really have no idea. But it works like shit, especially for a server-side rendering. Because now when you server-side render, which we started to do recently, it will show everything like mushed together, and then the client-side code we're running will actually lay it out really nice, which is a horrible experience because it glitches. So I've decided to, I don't know, be sober again, and like to be a normal person again, and to like use flexbox positioning for this. And this is one of the cases in which I mentioned before, I want to change a lot of things in the code, because as you would imagine, before it was like an absolute thing inside the relative containers, and the classes were attached to all these nodes. Now it's a completely different structure. So the code changed a lot, like not a lot, but you know, a few hundred lines of code. The UI changes that I want to attain is like 0 pixels need to change. Like everything needs to stay the same, and I want to make sure of that, okay? If I have snapshot testing using Jest, this is a non-starter. Everything will change, every line of code that I touch. So I will show you what happened the first time that I tried to run this. And actually not this one, but this one, okay? So as you can see, Chromatic runs across alongside all the other checks. And you will see here, there are 15 changes denied. So what happens is it runs, the diff, and it found 15 differences, which is 15 more than I expected. So let's take this one, for instance. Okay, and this one is similar to the one I've shown before. I messed up the layout of the date range component. So what I've done is to go on this build, and I have an interface. Now it's not the latest build, so I cannot do anything because there's a more recent one in this branch. But what I've done is to go and say, nope, that looks wrong. And I denied it, so that shows up as a as a red cross as a red X in the pull request. Okay, so you can see here that it's actually very easy to catch a few of the errors that I completely missed while developing because I wasn't focusing on this component specifically, but I was editing some common CSS across all inputs, so I messed it up. And it would have been terrible because this is used by like 5, 6 components. So you can see I messed all the things that I've messed up. So I completely screwed up errors, read-only states, and everything goes on. So you will see in the pull request that there were like a few more increments, a few more commits, and I managed eventually to get a green, which means I didn't need to change anything here. So we're fine. Of course, there are legitimate cases in which you're adding a thing or changing something, in which case you can just approve. Okay, that's something that I expected to see. So, okay, you approve, and then you merge, and then that's your new baseline. Okay? And by the way, these are the code changes, so you can tell why this is not very useful. This is what you will get, essentially, with a snapshot test. I mean, it shows you for completeness, but it's meaningless. And, well, the class names look like that, but that's a different story. Okay, so hopefully I'm selling you on the idea. Okay, so the other cool thing about this whole process is that I would have a storybook anyways. So that's a very cool thing that actually makes me like the project very much, the Chromatic product, because I will have a storybook anyway. The only thing I need to pay attention to is that now I want to have as many stories as possible because I know they will get screenshotted. So maybe in a development environment, you will just be happy with 1 or 2 stories with the initial state, and then you use the controls to move around and change things and see how they look interactively. But now I kind of want to have like a lot of like these permutations. Like, yeah, let me make sure that when the button is disabled, it has an icon, it looks like this, okay? Because I know they will get screenshotted. But there's like basically 0 overhead into testing this stuff, so I can have as many as I want. The only limitation here, I think, is money, because they will cost a few cents each. Multiply per the number of things this thing runs. But, I think it's a very, very win-win situation here for testing and development. By the way, there are other kinds of tests. Sometimes you want to test interactions or test other things. By the way, Chromatic also supports that. Storybook itself, you can run it locally, so you can attach a play function to stories, which has 2 purposes. So purpose number 1, you can get into a specific state that you want to screenshot. So for instance, this component does not have a declarative way to open the calendar. So there's no open the calendar prop on the component. So if I want to screenshot the calendar as it's open, I will basically do this. So in the play function, please get a button, which is the calendar button in this case, and open it. Click on it and open it. And Chromatic is gentle and is nice enough that it will essentially wait for the thing to finish, and then it will screenshot the thing. So it gets you into a state that you wouldn't get to otherwise. And it saves you the hassle of like figuring out a way of using props to do this. The other one is test assertions. So you can actually do the thing and say, hey, I want to make sure that this type email is actually forwarded to the component because that was a bug that we had. So I can have a play function which says, hey, by the way, check the text box that you're rendering and make sure that the type is email. So you can actually have unit tests of sort here inside the play function, and this will run in Chromatic, so you have a test runner also. So if you're already using Chromatic, you may want to do the same thing, essentially. Okay, that's what I have for testing. I don't know if you are already thinking of questions. In any case, there's a usual QR code that we'll show in the end. And I will get a sip of water because the next topic is going to be interesting. All right, you asked for it. My bad. So the problem that we are trying to solve here is this one, essentially. So sometimes you see broken interfaces because the localization did something wrong, or maybe you're showing the localization key. So this is a random screenshot that I got from, I don't know, is this Linux? I don't know, probably. Anyways, sometimes you do things wrong with localization, and the reason usually is that you don't have a way of checking that something is localized when you component, so you need to make sure that you have processes and tools around that. But I would argue that we could do something cool in TypeScript, and I will show you what. So the root code is something like this. So suppose you have a component, the component has a label, and the label accepts a string, right? Because you need to render that string. So in the first case, the string is wrong because we forgot to translate it. In the second one, it's our nice translation string. So T is come from like a i18x library, but it could be anything. So This is good, this is bad, but from a type system point of view, that's a string, right? Can we do any better? Can we do stuff like, hey, I don't want a string, I want a string that is actually localized. Can I distinguish the two, okay? Ideally, I would like to say, hey, this is a localized string, which is actually a string, but it's localized, right? So this doesn't work for many reasons that it would take a lot longer to explain, but this is transparent. So this is for you to read the code, right? This is not something that the compiler cares about. The type checker of TypeScript will see right through and call your bluff and tell you, oh, that's a string. I know it's a string, so I can accept strings when you ask me for a localized string. So we need something more than a string. Like a little something more. So in TypeScript, we can model that saying string and something else. So this is not some TypeScript you didn't know about. This is a placeholder, okay? So it could be string and something else. But what else? Okay, buckle up, because this is not for the faint of heart. So that's a thing, and consider that to be a thing. You don't need to understand it. I don't have time to explain it, but it's a thing, right? So it's string plus a thing that is unique to this type. So now we're saying, hey, TypeScript, by the way, localized string is not just a string. It's a string with something extra, okay? You may call this a brand, and that's why sometimes these things are referred to as branded types. It's not the only way of representing a branded type, but it's a way. So you may have seen like Zod libraries referring this to as a brand type. It's kind of the same thing, okay? The mechanism is not too important. It's important is the concept. So this is not a string anymore. So the properties of this thing now is that if you have a function that accepts a string, you can pass it a normal string or a localized string, and that will be fine. And that will be fine, by the way, in the second case, because a localized string is also a string, which is not always what you want. Sometimes you want to keep them things separated, so that it doesn't even know it's a string. I have examples, but I don't have the time to explain it. So again, a question for later. So if you have a function that accepts a localized string now, this gets interesting because the first string is a label, so it's a localized string, so it's fine. But if you try to pass a string to it, it will say, no. So this string does not have the little something that the other one has. So it doesn't have the extra thing that we put in there, so I'm not going to let you pass it to this function, which turns out is what we want here. So the first case will error now because this is not a localized string. And assuming that this T function returns localized strings, this is, okay? So how do we create a localized string? Well, we cast it, okay? We cannot really create that weird type that we had before, so you always need to cast. So this is all a make-believe for the compiler, but at runtime, that thing is a string. So you need to convince TypeScript that this is being translated. Trust me, we're just attaching some type information to it to make sure that we know it's translated. But at runtime is a string. The cool thing is that casting is really bad, but sometimes you need to cast. If you do it in a controlled environment, like in a specific function, that's okay, because nobody will know. It stays inside the function. So in practice, you will find on the Bento website, if you're curious how to do this in practice for like React i18next and React Intl. i18next is a little bit nicer because you can do it modifying the native types. But you essentially need any function that produces localized strings, and then you're done. So whenever it goes through your localization logic, it will spit out as a localized string. Okay, this was the easy part of this section. Do I have all you with me? Someone is very confused. I get it. But to recap, we're saying, hey, we're differentiating only at the type level between a localized string and a string. We're using a bunch of tricks. But at runtime, the thing is a string, so it can be used by the runtime to show it on screen. But you can now build safeguards around it, so you can have components that only accept localized strings. But maybe you don't want any of this, right? So this is what I would do in my project. But if I'm building a library, maybe I don't want this as a default behavior, because that's really hostile to the users. So imagine that you have a library, imagine that it's called Bento, and imagine that it will do this to users, and users are like, oh, Jesus, I need to interact with Bento now. I need to produce localized string. I need to do all this voodoo magic with TypeScript. So it's really annoying, right? So what I would do as a library author, which is what Bento does, and I want to explain how it does it, is to say, hey, by default, that thing is just a string. You know, localized string is just an alias. But now, if you want, you can opt in, and with some more TypeScript magic, you can say, no, give me the good stuff. Give me the localized string that will yell at me if I pass in a string, right? So what I want to explain now is how to make this behavior configurable from the outside within a library. So the library will give you essentially an API to change the type of something that is exposed in the public interface. Buckle up. Okay, let's start from some basics. So declaration merging is a thing in TypeScript. So I just want to touch on a couple of concepts in TypeScript because otherwise we're not going to go very far. So interfaces are open in TypeScript, which means you can have within the same module, you can have, people tell me to speed up, don't worry, but we have plenty of time. So in interfaces in TypeScript, you can essentially declare them multiple times, and as long as you're not conflicting in the declarations, and as long as they're within the same module, and we'll get to a module in a second, they will get merged. So if you had two boxes, one with the height and one with the width, you can actually do this, like this is valid TypeScript code, like you put it in a source file, and this is what the type checker sees. So it would just mush things together. And this is an amazing feature for many different reasons. By the way, there are rules. So you cannot just say height number, height string, because this doesn't override anything because there's no order. Like these things don't have a natural order. It's not like since you've written this, like on the bottom, it takes precedence or something. So they're like at the same level. So TypeScript cannot discriminate. It will not do fancy things like say, hey, maybe you want number, union, string. No, that's not what's going to happen. You're going to get an error. So don't do crazy things. Another property of TypeScript, which is interesting, is module augmentation. So imagine there is a library, which is called myModule, and exports a box interface. What you could do, you can augment it using module augmentation. So module augmentation is a technique which basically lets you open a module and put things in it. So you can say, suppose you have a library with no types. You can think of a library with no types as an empty module. So if you want to provide types, you say declare module, myModule, and you add all the types, and now those two things will merge. So TypeScript will do essentially the same thing of merging any declare module name of the module together. So the cool thing now is that if you put together the two, you can do open a module, add an interface, which was already in the original module, and those two things will get merged. One typical example is this one. So sometimes you want to attach things to Windows. Maybe you have like an analytics library that typically, for some reason, attach themselves to Windows. So you want to type that. So what you do is open up the global module, which is something defined by the DOM types, hook into the window interface, which already exists, and it's the type of the window object, and add your own stuff, and it will be added to the window object. So now you have window.logPageView, and it will work in TypeScript. So these are two things put together. So suppose our library then can intentionally use this feature by providing an interface that is only there for the user from outside to extend. So you have something which is called type overrides. It could be named anything, which is empty. And then you have something like base types, which is internal. It's your thing, and these are the defaults. So by default, localized string is a string. And we have some logic to mix up the two. So what we'll do concretely, this is a type utility, take it as it is, but it's override base types with type overrides. So what we're gonna do conceptually is to take the defaults, and if in that interface you find anything that overrides, so if you find that secondary definition of localized string, please use that one, because that one is more important. So by default, this thing will essentially be a string, because the interface is empty. But from the outside, you can do this and say, hey, let me open your library. Let me add a type override, because I know it's there. And let me say the localized string is the strict version of it. And by the way, we export the strict version ourselves, so they can mix and match it and use it. So now, by doing this trick, you can change the type of localized string, and it works. So now, since we're using localized string in all our components, if you do this magic thing, we can essentially allow you to override it and to make it the stricter version. So I don't know if this thing has a name. This pattern is used in libraries like React I18Next, which is what I borrowed this from, to type the keys. If you ever try to do that, to type the keys is actually the same thing. Remix has something like that for a context, like you have a context that is initially empty, but if you augment it with stuff from the router, you can say to TypeScript and add with the same mechanism the respective types. So to recap, what we've done here is to use branded type to avoid mixing strings that are not localized with strings that are localized, and then using declaration merging plus module augmentation to make these configurable from the outside. I hope you're all still alive. I hope you like this. So thank you very much.
Thank you, Gabriele. I loved the trick, and I will use somewhere.
I'm sorry.
No, it was really, really great. I love TypeScript. So, do we have any question here? Yep.
Hi, great talk. How do you test accessibility of your design system?
Very good question. So we don't yet have automated testing, but I can tell you what we do in other projects, in applications. So this also applies to design system, what I would argue. So there are a few automated tools that you can use. So I will mention a couple of them. And ideally, these tools should try to emulate. So the right question, the right answer is most of the things manually. Okay, so if you really care about like screen reader stuff, you need to use a screen reader. And ideally have a user who knows how to use a screen reader to do it for you. So if you're really serious about this, probably in the final product more than a design system, make sure that like somebody tests this using a screen reader, for instance, which is the hard thing to do. In terms of, again, automated tools, there are tools like Aqua, AQA, which are tools that allow you to write essentially scenarios in which you navigate a page. You could do it for a single component, and it will highlight things. And the interesting part is that there are things in accessibility that you cannot really automate. So it's from UsableNet, by the way, if you're looking at the UsableNet is the one you're looking for because maybe it's ambiguous. But the interesting thing about Aqua that we're using in a client's project is that sometimes we'll stop and give back control to you to check if it's something needs to be checked by a human. So sometimes there are no ways of testing these things automatically. So you can write a scenario in which a human interacts with the scenario and can actually check things manually and then move forward, and then the automatic stuff is checked. So I realize the answer is not specifically for design systems because most of the stuff that we do in Bento, for instance, is outsourced, so to say, to a library like React Aria, which has plenty of these tests. But yeah, it's complicated. It's a very complex topic. So there's no perfect answer yet. Thank you for the question.
Coming.
You spoke about vanilla extract. Well, you didn't speak about it.
I tried.
But what about Tailwind?
What about Tailwind? So I like utility classes. I like utility CSS, so breaking down small, one CSS class per property, essentially. I like the approach. I don't like the API of Tailwind specifically, so this is more like an opinion kind of thing. We use something similar. We use vanilla extract using sprinkles, which is a optional module of vanilla extract, which allows you essentially to define your own tokens, similarly to what Tailwind does, but it's not a string-based API. So it's an object-based API with full-on TypeScript support. So I like that more. So I like the concept. I don't like the tool specifically, but plus side of Tailwind is very, very friendly with AI. So if you're doing something quick, that's pretty nice. But yeah, that's all I have on Tailwind.
Okay, I have a question from here. Can you use a similar trick, the TypeScript trick, to localize string with React Node so you can check the children of a component, or is it only for string props?
Good question. No, unfortunately. So you cannot retroactively go, and so you would not apply this to native React nodes. So if you have like a div, it would not work. So the cool thing about design system is that you generally try to control as much things as possible. So even typography stuff. If you're using this React approach, there will be components. So for instance, when we work with Bento, there's basically no native HTML nodes. So we just use the React system components, and we have our own versions of everything. So even typography, even like regular divs, we use a version that has like a reset attached to it. So if you can control that, you're good. Otherwise, you're like only partly good.
Okay, more question? No? Okay, so another applause for Gabriele.